Good morning, welcome to today's class. Today we shall be having physics, and under physics we'll be looking at projectile motion. I have been able to draw this projectile diagram out so that we can save a lot of time. And under this I'll be giving some examples under projectile motion. Projectile motion under rockets. An example of projectile motion is release of rockets. Another one is when someone jumps using pole vaults. That's another typical example of projectile motion. Now, under projectile motion, we'll be learning derivation of formulas. And the derivation of formulas we'll be learning, talking about time to reach maximum height. Time to reach maximum height. Time to reach maximum height. And the time to reach maximum height we'll be needing the help of our knowledge from how to derive equation of motion, straight line motion, linear motion. So which is the first one, which is V equals to U plus AT. But because we're talking about projectile motion and objects are going up and they're coming down, we cannot be using A, which is acceleration on a straight line. We're going to be using G, which is acceleration due to gravity. And we're going to be changing this plus to minus because it is reaching height. So when something is going up, it has to be minus because there's a tendency that it can come down, and because it's going against gravity, so it's going to be minus. So, and anytime you see time to reach maximum height depicts that our vy, because it's going up, is going to be 0. So that means 0 equals to u minus gt. Bring gt to this side and make u to remain here. Making it of the formula, t becomes u over g. If you are going to be equating this using sine, we are going to be making it to become sine theta. So you can either say time to reach maximum height is u over g or u sine theta over g. And so now we are through with that. Now we'll move to the next one. So the next one I'm going to be doing the next one, which is time of flight. And you should know that time of flight is twice time to reach maximum height. So time of flight is actually twice time to reach the maximum height. So how do we actually get this? We can do it because I already have my knowledge that my time, my small t from what we have gotten before is u over g sine theta. So that means my t here will be what? 2u by g sine theta. And this is what we get as time of flight. Now, time to reach maximum. Now, next one is maximum height attained. Maximum height attained. Maximum height attained. This is time of flight. Capital letter T. For maximum height attained, we'll be using our third equation of motion, which is v square equals to u square plus 2as. But because the objects, we are talking about projectile and the objects are going up and they are coming down, we cannot use A, we are going to be using G. And I prefer to use H instead of using S. And then because object is going up, we are going to be using minus. So, and maximum height, so my Vy will be equals to 0 because objects are going up, so we cannot get our final velocity. We can only calculate for our initial velocity because the object is going up. So now I can just bring this one. I can just say 2gh equals to u square. Now from here, I want to make h sort of formula. H would become u square over 2g. Let me bring it up so that we can be able to see what I am doing here. I want to bring it up. So what I wrote down here was h maximum equals to u square over 2g. So this is this is the time to reach maximum. This is the maximum height attained when you are not giving degree. But when you are not giving to solve in an angle, when you are given an angle in a degree, you need to equate it to write sine squared theta. So u squared sine squared theta over 2g. So this is our maximum height attained. And then the last one, which is horizontal, which is range. So range is actually defined as the horizontal distance from the point at which the object is being released to where the object is going to, or where the object is going to be at. So for example, this is range now. You can see, so it's an horizontal distance from here to this particular point. This is our range. So the formula for our range is just ut. And then what is my t is what? My t is time of flight, and time of flight is twice time to reach maximum height. So time of flight is 2u sine theta over g. So my u, because I've already used sine here, I cannot be equating u also to sine. I have to use u as cos theta. So to write my range again, I'm going to write in u cos theta 2u sine theta. Let me write it as range is equals to 2u sine theta times u cos theta. When I multiply, I'll be having 2u square sine square theta cos theta. 2u sine square theta cos theta. Okay, no, sorry. 2u square sine theta cos theta. And so now you remember that from trig. Let me clean it. So from trig, we will recall that my marker is fading. We will recall that you recall that 2 sine theta cos theta is equals to sine 2 theta. Yes. So now what we are left with is just u square. What I just left with is just the u square, and then that's it. So from here we cannot get our range as so from here we can. So from here I'm having my 2 sine theta as equals to this. So sine theta, everything has now become, so we'll be left with just this, our range to be u square sine 2 theta, and then which is over g. Okay, I hope sorry, I forgot to include my g. I think I made that silly mistake, g and then gs, so that you don't forget that your range is actually u over gt. So this is actually your range. And so I forgot this because I don't know, when I was saying my t is equals to u sine theta over g, so I omitted the g. So this is now our formula for solving range. This is our equation for solving range, and that's that.